Hi there! Today we are going to walk through the Fingerspelling app. Fingerspelling is an iOS application that allows users to practice American Sign Language, or ASL, fingerspelling. We can see on the left menu that the app has two different modes: receptive mode and expressive mode. The expressive mode gives the user a specific word, such as steal, that the user then has to fingerspell. Users can check their spelling using the reveal button. The receptive mode allows users to see images of a hand spelling out a given word in ASL fingerspelling. The user can then enter the word they saw and reveal the correct word that was spelled. To accommodate different levels of users, the app has a nifty slider here at the bottom, which controls the speed of the fingerspelling images. We can see if we slide the slider towards the left or towards the turtle, the images appear slower. And if we slide to the right, near the rabbit, the images flash by faster. The Fingerspelling app also keeps track of some statistics, including the number of words a user has completed, as well as the current speed of fingerspelling images. Other settings on the Fingerspelling app include the ability to specify the maximum word length by the number of letters. Users can also enable and disable haptics. Today, I want to focus on the slider at the bottom of the page in receptive mode. As we have seen, users can adjust the slider to indicate the speed at which the images flash across the screen. Let's dive into the code to see how the slider works behind the scenes. So here we are in Xcode, and we're looking at the Fingerspelling app. We can see here on the left menu that there are a number of views, including the expressive game view, the navbar view, and the receptive game view, among others. Let's take a look at the receptive game view. First, notice these environment objects at the top of the receptive game view structure. If we take a look at our documentation, we can see that an environment object is a property wrapper type of an observable object supplied by a parent or ancestor view. We will work with these environment objects a little bit later. On lines 13 to 17, we are declaring some variables, including the min and max speed. We will also use these variables later in the code. We know we want to work with the slider object, which controls the speed of the images. And there are a couple hundred lines of codes in this file. Let's do a Command F to find where the word speed shows up in this file. Here we go. On line 295, we see a private structure called speed control view. This is the view that we want to look at. The speed control view will be the building block of our slider. Within this structure, we define some properties and methods. If we take a look at the Swift documentation, we could see that structures and classes are pretty similar. Structures are very similar to classes in that we can define properties and methods and initialize some state. On line 296, we see a binding variable value, which is of type double. Let's look at the documentation for this binding keyword. Binding is a property wrapper type that can read and write a value owned by a source of truth. If we scroll down, we could see that a binding creates a two-way connection between a property that stores data and a view that displays and changes the data. Let's look back at our speed control view. Here we are also defining some more variables, including the mid speed, the max speed, and disabled, which is a Boolean. We then define a variable body, which is of type SumView. Let's look at the documentation to see what SumView really is. SumView is referred to as an opaque return type. This means that the variable body conforms to the view protocol, but we don't have to specify which specific protocol that is. We are not required to write out the exact view type. This has some performance implications and allows for quick compiling, as the compiler does not need to figure out exactly what has changed. Within our body, we also see an H-stack, which is a view that arranges its children in a horizontal line. We also see an image of a tortoise. This shows the turtle image, which is to the left of our slider. And next, we have our very important slider. Let's look at the documentation for slider. A slider is a control for selecting a value from a bounded linear range of values. In our case, we initialize our slider with the binded value, we specify the possible ranges of values, and we specify a step increment of 1. So when speed control view initializes this slider, it passes the binding variable self.value into the slider's binding property. That way, whenever a user updates the slider, the speed control view also updates its value. A binding value is passed using this $sign. So we've initialized our speed control view structure. Let's take a look at where speed control view is called. Here we are on line 85, and we can see that speed control view is being called. This is where we are setting the attributes in the structure that was initialized below. Here we assign the speed value to self.$settings.speed, which is another binding variable that we get from the user settings environment object. We also assign the min speed, the max speed, and the disabled Boolean attribute. The disabled attribute allows the slider to be disabled when a word is actively being spelled. So if we take a look, usually we can just slide this slider freely, but when a word is actively being spelled, the slider is disabled and we are unable to change it. So we've gone over how the slider shows up on our application, and that's great. But how is the slider connected to the speed of the images? Well, at the beginning of this video, we noticed this environment object variable settings, which is connected to user settings. Let's take a look at the app state file. On line 207 of the app state file, we see this class user settings, which is an observable object. This is the class where app settings will be set, including the speed. Let's take a closer look at what an observable object is in the documentation. An observable object is a type of object with a publisher that emits before the object has changed. By default, an observable object synthesizes an object will change publisher. That's great, but I could use a little bit more context than what this documentation is giving me. So let's take a look at this blog from Hacking with Swift. How to use observed object to manage state from external objects. Here we can see that an observable object conformance allows instances of a class to be used inside views so that when important changes happen, the view will reload. That gives us a little bit of a better idea of what's going on here in user settings. On line 228, inside the user settings class, we see a variable speed, which has a default value of 3. Speed has a will set property, which allows us to run this code whenever the value speed changes. On line 231, self.object_will_change.send sends a value, which is speed, to the subscriber, which is our receptive game view. So willSet is called when we want the view to refresh with the updated speed. So to review, we went over how this fingerspelling app implements this slider, which controls the speed of the flashing images. We looked at how the receptive game view sets up the slider and how the speed is connected to the user settings through the environment object. Thank you for watching this video and have fun fingerspelling.